Welcome to the first of a series of projects dedicated to building CHUMP, which is a cheap, homebrew, understandable, minimal processor. This part of the project consists of making the clock, the counter, and also writing the code that will eventually run on the final CHUMP. In front of me here you can see the working clock and counter. The astable 555 output is shown by this LED here. The monostable 555 output is shown by this LED here, where you can see if I press the button, the light turns on, and the overall clock output is shown by this LED here. Finally, the current count of the program counter is shown by this bar graph right here. By the way, the bar graph is just 4 LEDs in a 3D printed sheath. You can see that if I turn this potentiometer, the frequency of the 555 will change, and so the counter will count at different speeds. By flipping this switch right here, I can change the counter into manual mode, where then if I press this button, you can see that it will step the counter. Changing the switch back, you can see that this button here halts the program counter while not halting the 555. Finally, by switching this slide switch back, you can see that if I press this button and then press the manual step button, that the value on these slide switches is loaded into the bar graph and the program counter. I'm not going to go too much into the clock part of the circuit because we already dealt with 555s last year, but the program counter part of the circuit is new. The program counter is largely built off of this chip here, which is the 74LS161 synchronous counter, which is actually quite similar to the 4561 used in the counting circuit from grade 10. This counter takes the clock input on pin 2 and with every rising edge increments its count by 1. Once the count reaches the maximum 4-bit value of 15, you can see that the counter rolls over. Much like the 4516, the 74LS161 also has a load feature, where by pulling pin 9 the load pin low, we can preload some set value into the counter. Loading values into the program counter is important because by doing this, we can jump to different lines in our program. This is how we implement branching in low-level assembly. This brings us to coding in Chumpanese, which is the coding language used for CHUMP. This language comes with 7 different built-in operations. Each operation has 2 flavors, one of constant and one of memory, which means that for the operand, you can either use some constant or you can use the value of some address in memory. This is denoted by the least significant bit in the opcode. Highlighted in light blue, you can see the custom instruction that I added to CHUMP. It's called if_neg, which is short for if negative. It works essentially like if0, except it jumps if the accumulator is less than 0. We can now take a look at my code, which decides whether or not input A is greater than input B. Input A and B can be decided by the value that you choose to load into addresses 0 and 1. The output will go into address 2, being either a 0 for it's not greater or a 1 for A is greater. Let's take a look at my code in action using the CHUMP VM. Starting off, we load 8 into the accumulator. We then store that value to address 0, and you can see it updates there. We then load 7 into the accumulator. We then store to address 1, which also updates. We then read from address 0, and we load it into the accumulator. We then read from address 1, and then we subtract it from the accumulator. So we're doing 8 minus 7, which, as you can see, gives us 1. We then use the if negative function, which will jump to line 10 if this value is negative. However, it's not, so it will then increment to line 9. Line 9 tells us to go to line 13, where we load 1 into the accumulator, and then we store it to address 2. We then go to line 0. What this tells us is that input A was indeed greater than B because address 2 now has a value of 1. And we can see this is true because 8 is greater than 7. One final thing that I would like to show is this CHUMP compiler that I made for this project. If I go ahead and run this processing sketch, you'll see that the CHUMP compiler opens in a new window. In the CHUMP compiler, you can code in assembly level CHUMP and it will output the machine code for you to processing, so you don't have to do the manual translation. For example, I'll go ahead and write some quick code here. Here's my quick example program, which does nothing special, but the special thing is what happens when I compile it. To compile, you first choose the number of lines that you want to compile, so I want to compile 6 lines here, and then if I press the compile button, and we go over and look at processing, we can see that the machine code has been outputted into the terminal. You can see that if we do some unallowed action, like compiling a blank line, and we click compile, the IDE will catch that error and tell us where it is, instead of crashing. By the way, it used to crash if you did anything wrong. So yeah, that's about it. Thank you for listening.